You know all that used cooking oil from restaurants, from your own kitchen? Ever stop to think about where it all goes? Well, most of it just becomes this greasy, hard to dispose of waste. But what if we could take that problem and turn it into a solution? Today, we're going to dive into some incredible research that does exactly that, transforming everyday waste oil into a clean burning fuel.
So the mind behind this work is Dr. Mahmoud Karimi. He's a real expert in sustainable energy, collaborating with places like Stanford and UC Davis. And his whole area of focus is this amazing field called waste valorization, which is really just a brilliant way of saying he finds value in the stuff we throw away. I mean, what a perfect mindset for tackling a problem like waste cooking oil, right?
It almost sounds like a movie plot, doesn't it? But that's the exact question at the heart of the research we're looking at today. It comes from a paper in the journal Environmental Technology, and it details how to take that waste oil and with a bit of, well, chemical magic, create something incredibly useful.
And let's be clear, this isn't just some neat lab experiment. It's a direct shot at two of the biggest challenges on the planet. First, we're all hooked on fossil fuels. And second, we're creating more and more pollution from waste products. This research, it tackles both at the same time. It literally turns the pollution into a replacement for the fossil fuel.
Okay, so the official scientific term for this process is transesterification. It sounds complicated, I know, but the idea behind it is pretty straightforward. It's the chemical reaction that changes the molecules in oils and fats into the molecules that make up biodiesel. Simple idea, but making that reaction happen efficiently, that's the real trick.
So to get a chemical reaction to really kick into gear, you need something called a catalyst. Think of it like a chemical matchmaker. It brings the right molecules together to get things going, but it doesn't get used up itself. Now, the old ways of doing this often used harsh chemicals, messy, hard to clean up. But this study, it introduces something way smarter.
The way they build this thing is just fascinating nanoengineering. First, they create a tiny magnetic core of iron oxide. You can basically think of it as a microscopic speck of rust. Then, they coat that core with a shell of something called mesoporous silica, which is like a tiny sponge with tons of little tunnels all over it. And for the final step, they attach a natural enzyme, lipase, all over the surface of that spongy shell. This enzyme, that's the real workhorse here. That's what's going to do the heavy lifting.
And this design is pure genius. That magnetic core means that when the reaction is done, you don't need some complex filtering system. You just grab a magnet and poof, you pull the catalyst right out of the liquid. That porous, spongy shell, it gives the enzyme a massive surface area to do its job, which makes the whole thing super efficient. And that same shell actually protects the enzyme, giving it a safe, stable home to work from.
All right, so having an amazing catalyst is one thing. But if you want this to actually work in the real world, you need to know the exact, most efficient way to use it. You can't just guess, right? What's the perfect amount of catalyst? What's the perfect temperature? How long do you let it cook?
The team really narrowed it down to 4 key variables they had to get just right. First, the ratio of methanol to oil. See, too little in the reaction fizzles out, but too much can actually hurt the enzyme. Then, there's the amount of the catalyst itself. Third is water content. Enzymes need a tiny bit of water to work, but too much will ruin the whole batch. And finally, of course, there's the reaction time.
So how in the world do you find the perfect mix of all those things? Well, instead of the old, slow way, changing one thing at a time, running hundreds of tests, the researchers used this really powerful AI hybrid approach. They ran a few strategic experiments first, then fed that data to a smart computer model that could predict the outcome for any combination. Then, they unleashed a genetic algorithm, which is this cool AI inspired by evolution to search through all the possibilities and just zero in on the absolute best recipe.
And this is really what makes this research so next level. It's not just brilliant nanoengineering, it's pairing it with intelligent predictive modeling. They didn't just find a good way to make biodiesel. The AI found them the mathematically optimal way, and it probably saved them months, if not years, of lab work.
So what was the result? Get this. The AI predicted that under the absolute perfect conditions, the right methanol ratio, the right catalyst amount, a little bit of water, and a 6-hour reaction time, they could get a maximum yield of 91.2%. That means over 91% of that nasty waste oil was successfully turned into high-quality fuel. That is just a phenomenal result.
But hey, a great yield is only half the battle, right? If you have to make a brand new, expensive catalyst for every single batch, well, the whole thing falls apart economically. It's not sustainable. So the real test for this magnetic nanocatalyst was, can you use it again and again
And here is the other jaw-dropping finding. After they used it, pulled it out with a magnet, washed it off, and threw it back into a new batch, it was still incredibly effective. Even after being reused for 4 full cycles, it kept nearly 90% of its original power. That right there is a total game changer for making this process affordable.
So when you put it all together, what does it mean? What Dr. Karimi and his team have created here is way more than just a lab curiosity. It's a blueprint for a genuinely sustainable process. It's clean, no harsh chemicals. It turns a pollutant into a valuable product. That's waste valorization in action. And because that catalyst is so tough and reusable, it has a real shot at being cost-effective on a huge scale. It's a real step towards a circular economy.
This whole thing just leaves you with this one final, really inspiring question. If we can use smart science and a bit of AI to turn old fryer grease into clean fuel, what other waste are we just completely ignoring? What other hidden treasures are just sitting there in our trash, waiting to be unlocked? The potential is just absolutely staggering to think about.